Hello, today I will discuss the moment of couple. This is again a very important topic of engineering mechanics. It helps in solving many complex the problem we face in daily life. So to understand what is a couple, we consider a simple case, a real problem. So a bottle which is filled with a fluid, and this black one is the cap of this bottle. So whenever we open this cap, then a torque is acting on this cap, okay, and so it means there will be two forces acting on this cap. And if you want to make the force diagram of this cap, then we can see here. So this is the cap, and then one force is acting in this direction and another force is acting in this direction. Okay, so two forces are acting on this cap when we open it. And now if we look at the nature of forces, then what we observe that both forces are same in magnitude. And if I extend the line of action of this force, and if you extend the line of action of this force, then what you notice, the line of action of both forces are parallel to each other. Okay, so both forces are also parallel to each other and acting in opposite direction. Okay, so both forces are acting in opposite direction and both forces are parallel to each other. So this is what we call a couple. It means the couple is formed. Okay, so couple is formed by same magnitude forces acting on a body in opposite direction and parallel to each other. Okay, so this is what we call a couple acting on a body. Now, what is the moment of a couple? So to understand the moment of couple, let's consider again a simple the object or the body in a given plane. Okay, so this is the circular object. Let's say it is rolling on the plane, the perpendicular to the forces acting on this body. So this is the center of object, and let's say one force is acting at this point and another force is acting at this point. Both forces are of same magnitude and acting in opposite direction to each other. Okay, so this is a couple acting on this body. Now if you extend the line of action of this force, okay, and if you extend the line of action of this force, then the distance between these both lines of force is d perpendicular. So the forces which form a couples are always non-collinear. Okay, because the line of actions are not passing through a common line. Okay, so line of action of both forces are different and both forces always lie in a given plane. It means both forces are coplanar forces. So the moment of this couple we can define by the magnitude of the force, because both forces are in same magnitude. So we can write, or we can consider a magnitude of any of both forces. So magnitude of the force multiply with d perpendicular. It means the force into the perpendicular distance between the lines of x and of f. So this is the magnitude, this is the magnitude. Okay, so this is the magnitude of moment of couple. Now similar to the moment of a force, the moment of couple can also be a vector quantity. Okay, it has magnitude as well as the direction in a given plane. So to understand the direction of moment of couple, we consider the two cases here. In the first case and the second case, in first case we consider the body here. Okay, so both forces F, this force and this force, both are non-collinear and acting on the body in the same plane. And if I extend the line of action, so the line of action of this force is here, line of action of this force is here, and the distance between the line of action of the forces is, let's say, the d. Then magnitude. Okay, so the moment of couple in case 1 is F into d, and we consider the second case. Okay, so in second case again the same object, and couple is acting on this body in a given plane. And if I draw the line of action of the forces, and the distance between the line of action of the force is d, so the magnitude of the moment, okay, so the magnitude of the moment of couple is F into d in this case also. Okay, so in both cases, even the direction of the forces are in opposite. So in this case the couple is acting in different direction, but the magnitude of the couple of moment is same. Now, so what is the direction of the rotations due to this moment of the couple, or what will be the sign convention, or what will be the direction of this moment? Okay, so to understand the direction of the moment, a couple of moment, we can look at here. So this couple, if you look at this couple, and this couple has tendency to rotate this object in this way. Okay, so if you look at here, then this couple will rotate the object in the anti-clockwise direction. Okay, so the direction of moment of couple is anti-clockwise in the case. And if we look at here, then what we observe, so this force, this couple has tendency to rotate this body or this object in this direction. Okay, so the direction of the rotation of the body due to this, the moment of couple, is in clockwise direction. Okay, so this is the clockwise. So we can write the moment in this case F into D, and then the direction will be the anti-clockwise, and for this case M equal to F into D, and direction will be in clockwise. Okay, so for the clockwise we consider the positive, anti-clockwise we consider the positive sign, and for the clockwise the direction we consider negative sign. Okay, so whenever the moment of a couple will be in clockwise direction, then we will consider the positive sign, and if it is in the clockwise direction, then we will use the negative sign. Okay, so now this was the how we can estimate the magnitude of a couple acting on a body, as well as the direction of that couple, or direction of moment of that couple. Now, so we can summarize a few properties of couple or moment of a couple here. So first is that the couple only rotates body. It means that if we take the moment of a couple, then this moment, if moment is non-zero, it means this couple will rotate the object in a given direction, but this couple will never provide a translation motion to the same object. Okay, it means even the net forces acting on the body is zero, but if the couple is non-zero, sorry, the moment of couple is non-zero, it means body will rotate and the translation motion, so the shifting of body from the one point to another point will be due to the rotation, it's not due to the translation. Okay, so couple means this moment of the couple is only responsible for the rotational motion, not for a translation motion. The point is that the couple of moment can be added like scalar quantity. Okay, so similar to the moment of forces or any vector quantity, we can also add the moment of couple acting on body like a scalar quantity. Okay, so by using proper sign convention. Okay, for the clockwise we will use negative sign, for anti-clockwise we will use positive sign whenever we do the algebraic sum of the moments of couple. The third point is that the couple does not have a moment center. It means we will never estimate the moment of a couple about a given point. Okay, but in case of the forces, okay, we will always estimate the moment of a force about a given point or about a line passing through a given point. But in case of the couple the moment of a couple does not depend on a given point. Okay, it means we do not consider the points, or we do not measure the moment of couple about a given point. Okay, so these are the main properties of couple and moment of couple. So now if I proceed further, that there is one very important property of a couple is that the couple is a free vector. Okay, so what does it mean? I will discuss after doing some mathematics. So to prove this statement that the couple is a free vector, I will consider three different cases. So let's say if I consider again a body, and a couple is acting on the body. Okay, so this is the couple is acting on this body. The magnitude of the force is F, and if I draw the line of action of both forces, then this is the D. It means the distance, perpendicular distance between the both forces is D. Okay, so now I can write the expression or the formula for the moment of the couple, or the value of the magnitude of the magnetic value of the magnitude of moment of a couple in this case. Okay, so I can write here. So let's say in this case I define the moment of couple is m1. So m1 is the magnitude of the force F and perpendicular distance D between the forces. And if you look at the diagram, okay, so couple acting on this body. So this couple has tendency to rotate the body in this direction. So this is the anti-clockwise direction. Therefore I can express the moment of this couple and direction is anti-clockwise. Okay, so this is the moment of this couple. Now consider the case 2 for the same object, and so again the same object or same body, couple is acting here. Okay, so this is the couple is acting on the body. This is a similar case what I discussed. So now we can also estimate the moment of forces. Now let's say this is the center point O here. Okay, and then the line passing through the center is this one. So the distance between this force and the line passing through point O, it means the distance between the point O and this force is d by 2, and similarly the distance between this force and the line passing through this point O is d by 2, or we can say the perpendicular distance of this force or line of action of this force to point O is d by 2. Okay, so now I can estimate the moment of forces, because two forces are acting on this body, and the point I want to measure or want to estimate the moment of both forces about point O. So moment of forces about point O. Okay, so I can write, so this is the two moments, and we can add the moments algebraically or like a scalar quantity with sign convention. So the moment of this force F into d by 2, moment of the second force is also F into d by 2. Now if you look at, so this force has tendency to rotate this object about point A or O in this direction. This force has the tendency to rotate this body about O in this direction. It means the direction of the moment of this force will be anti-clockwise, and direction of the moment of this force will be also anti-clockwise. Okay, so the direction is anti-clockwise and the direction is also anti-clockwise. It means we can use the positive sign. So net moment. Okay, so now I writing so I can write prime here, m1 prime, m2 prime. Okay, so m2 means the case second, net the moment of forces in case 2 is m1 prime plus m2 prime. Okay, so this is f into d by 2 plus f into d by 2, and this is nothing but f into d by 2 plus d by 2 equal to f into d, and the direction, because both are in positive. Okay, so the direction of this moment is anti-clockwise. Okay, so this is m2 is moment of these forces. Okay, moment of these forces about point A. Or we can say, okay, so now I consider case number 3. Again the same object, same couple of force. Okay, this couple of forces. Now I consider a point A here, and I want to measure the moment of both forces about point A. So now to get the moment of both forces, so the line, I draw the line of action of this force here, the line of action of this force here, and then the distance between point A and this force is d1, and distance between point O and this force is d2. Okay, so now I can estimate the moment of forces about point A. So for case number 3 I writing m3. Okay, so moment of both forces about point A is m1 plus m2. m1 means moment of this force, so force value is F magnitude, and distance is d1 plus force into distance d2. Okay, now so first we can estimate separately and then we can use here. Okay, so now first, what is the m1? m1 is F into d1, and what is the direction? So this force has tendency to rotate the object or this body about point A in this direction. Okay, so this force, and this force has tendency to rotate the body about point A in this direction. So m1 is F okay, so and direction is the clockwise, and for the m2 F into d2, and direction is okay is anti-clockwise. So we will use the sign convention for the now m1 is minus F into d1, and m2 is anti-clockwise, so we are using the plus convention, sign convention, and d2. Okay, so we can write F into d2 minus F into d1, or we can write F d2 minus d1, and d2 minus d1 is nothing but the d. Okay, so F into d. and not positive value, so this is again anti-clockwise. Okay, so direction will be anti-clockwise. So now if you compare, okay, now if you compare the moments of all three cases, case 1, case 2 and case 3, okay, so now compare. So after comparing, moments of all three cases, what we observe, we observe that m1 is equal to m2 is equal to m3. It means the value of m is f into d and the direction is anti-clockwise in all cases. Okay, so this is the magnitude. So m1, m2 and m3 in all cases have the same magnitude and the direction. Therefore we can say that moment of couple is constant. Okay, so moment of couple is constant and independent of any point. Therefore we can say that couple is a free vector. Okay, so this was all about the couple and moment of couple and its property. Thank you.